All right, this question asks us to represent the area that's bounded by the given curves. It's asking us to represent this area as an integral. And our function, or functions, involve one piecewise function, f of x, and one straight line with slope 0, the line y equals 12. And also an x value of x is equal to 10. So a picture is provided, otherwise the question is next to impossible. And looking at the picture, the area bounded by the curves, I can pick off the locations where I have to find x coordinates. The lowest bound on the integral I'll call A. It'll be right there where those two curves cross. The next bound on an integral will be B, and that's given by the picture. That's where the piecewise function switches. So we could tell this piecewise function switches at 7 from f of x up above. That means that B is going to be equal to 7. So I'll write that down. Place f of x switches. And the last bound is at the very end. Where we stop integrating, I'll call that C. And we can tell that that's going to be 10 from the question. So what we can tell right away is that our area is going to be an integral from a to 7 of the top function minus the bottom function plus an integral from 7 to 10 of a top function minus a bottom function. Okay, so we're going to go from a to 7, and inside that area, which function is on top? Well, it's the blue curve, and the blue curve corresponds to f of x. The part of f of x that's for x less than 7, so it'll be 8 plus 2 log base 2 of x plus 1, and then the bottom curve is the 12, y equals 12. And for the second part, going from 7 to 10, now the red curve is the top function, so the top is 12 and the bottom is our blue curve, which in that case for x larger than 7, it's 1 plus x cos of x. Okay, now each of these can be simplified. So we have an integral from a to 7 of negative 4 plus 2 log base 2 of x plus 1, it's combining the 8 and the negative 12. And then we can simplify the last one, integral from 7 to 10. We have 12 minus 1, which is 11, minus x times the cosine of x. And we can look at the options and eliminate anything that doesn't fit. Oh, and I see there's a little typo here. There should be 10 up here. I'll fix that before hopefully anyone does the quiz. Not that it matters, it's wrong. That option is incorrect. It doesn't match the format that we have. So I'm going to cross it out. And then we have a next one. We have we're going from 2 to 7, negative 4 plus 2 log base 2. So everything matches, except I'm not sure if that lower bound is correct. If that lowest bound at the start there on the integral is supposed to be a 2 or not. So I'll hold off on selecting it. The next one, instead of having negative 4 plus 2 log base 2 of x plus 1, we have 4 minus that. So I'm going to cross that one out. It doesn't fit. And then D is also like that. It's wrong. It has the wrong order. So we'll cross that one out. And then we have E, which is just like B, except the lower bound is 3, not 2. So unfortunately, we're going to have to find that lower bound. We need to find out, are we going from 3 to 7 or are we going from 2 to 7? And we can't use a picture to do that. So how do we find A? find A from intersection of, well, the region of the blue curve that we're looking to intersect with the red line. And the region of the blue curve that we're interested in is the region that's less than 7. So I'm going to set 8 plus 2 log base 2 of x plus 1 equal to 12. I'm going to set the y value of one curve equal to the y value of the other curve and solve for x. Subtract 8 from both sides, so 2 log base 2 of x plus 1 is equal to 4. Then divide both sides by 2, so log base 2 of x plus 1 is equal to 2. Then exponentiate, raise both sides as powers on a base of 2. So it's been a while since we've had to do that. But there it is. So we get x plus 1 is equal to 4, and that means x is equal to 3. So it is going to be E as our correct option. We're going from 3 to 7 and not going from 2 to 7.